Hey everyone, and welcome back to The Explainer. Okay, today we are running a really exclusive high-stakes strategy session. If you're studying for Cambridge Information Technology 9626, you already know that mastering this syllabus, well, it's not just about memorizing a bunch of facts. It's really about understanding exactly how the examiners want you to think. So today, we're totally decoding Topic 16.2, Specifications. We're going to cover user requirements, system specifications, and design specifications. We're basically going to break down the examiner reports, reveal some hidden pitfalls, and unlock the exact framework you need to get maximum marks. So get ready, because this is literally your blueprint for exam success.
Right, let's jump straight into this with a number that should absolutely grab your attention, 15%. Did you know that Topic 16.2 accounts for roughly 15% of the total marks in Paper 2? Seriously, that is a massive chunk of your final grade sitting right here in this one single topic. You literally cannot afford to leave these marks on the table. Mastering this stuff, it's not optional, it is the absolute cornerstone of a top-tier paper.
So how exactly do we capture that 15%? Well, here's our game plan for today. First up, defining specifications. Second, assessment objectives. Third, the procedural framework. Fourth, critical analysis mastery. And finally, top examiner warnings. Stick with this roadmap and you'll be set.
Okay, kicking things off with Section 1, defining specifications and core terminology.
So look, logical reasoning requires completely unshakable foundational knowledge, and that starts with separating three really critical domains: user requirements, system specification, and design specification. To show the examiner you know your stuff, you've got to precisely define and separate these three. Think of user requirements as the what, like what does the end user actually need the system to do? System specifications translate that what into the technical, hardware, and software requirements. And then the design specification is the detailed how. How is this thing actually going to be built? If you blur the lines between these three on your exam, you're going to lose the examiner's confidence right out of the gate. You have to keep them distinct.
And honestly, this brilliantly illustrates our next major point, which we pulled straight from the principal examiner reports. Quote, candidates referencing cross-topic connections achieve significantly higher marks. The syllabus practically screams that top-performing students show a connected, conceptual understanding that they can transfer over to completely unfamiliar contexts. You can't just memorize isolated definitions here. You've got to ask yourself, how do these specifications impact database design? Or how do they affect networking choices? If you integrate these specifications with the rest of your syllabus knowledge, I promise you, your marks will absolutely soar.
Moving right along to Section 2, assessment objectives and measuring performance.
All right, let's shift gears and focus on the specific cognitive domains examiners are actually measuring when they grade you. The framework targets three distinct areas: knowledge and understanding, application, and analysis. But here is the absolutely crucial takeaway. The framework heavily prioritizes analytical depth over superficial breadth. Like simply listing 50 random facts about a system specification, that just falls under basic knowledge. Applying it to a given scenario is definitely better. But analyzing why a specific design specification is superior for a given context, bingo. That is where the highest grades live. Examiners want deep analytical reasoning. They don't just want a shallow list of buzzwords.
Which brings us perfectly to Section 3, the procedural framework and the method mark strategy. Now, I know a lot of students really struggle with multi-stage analysis, but we can totally fix that by just focusing on the process. Let's walk step by step through the exact deconstruct, solve, evaluate pipeline that the highest scoring candidates use. Step 1, identify the given information from the scenario. Step 2, break the problem down into logical steps. Step 3, solve it systematically. Step 4, check for reasonableness, meaning, does your solution actually make sense in the real world? And finally, Step 5, make justified recommendations. Listen, if you follow this pipeline, you are practically forcing the examiner to hand over method marks at every single stage of your answer.
So what does this actually look like when you're writing on the exam paper? Well, data interpretation skills are just vital here. You have to extract relevant data from the texts and tables they give you. Then you select your analytical framework, execute it using clear notation, and present your findings with the correct professional terminology. You've got to interpret the relationships in the data to draw real, evidence-based conclusions. Because honestly, if you aren't pulling specific data out of the text to back up your points, you're not really analyzing. You're literally just guessing.
Okay, Section 4, critical analysis mastery and evaluating alternatives.
All right, now we're entering the major leagues.
Top-scoring candidates don't just describe a system, they evaluate the alternatives. Instead of just stating a descriptive fact, something basic like, the system uses a cloud database, evaluative thinking actually questions why the cloud was chosen over local storage, specifically based on the user requirements provided. Top students compare approaches, they question underlying assumptions, they look at different perspectives, and most importantly, they justify their decisions with hard evidence. At the very core of this comparative analysis is the absolute mandate to identify similarities and differences. You've got to use comparative connectives, words like whereas or however or in contrast. Support each comparison with evidence straight from the text and, crucially, draw a conclusion about their relative importance. Which factor actually matters most to the user, and why? That is exactly what the examiner is desperately hunting for in your answer.
And finally, Section 5. Top examiner warnings and how to avoid easy mistakes.
Okay, we're going full boot camp mode here. Let's look at exactly where students just bleed easy marks. Here are the top 3 massive pitfalls, straight from the people grading your papers. Mistake number 1, missing the proper format. Look, if the question asks for a design specification and you write a giant generic essay, you're losing marks. Mistake number 2, ignoring format and presentation checks. Your professionalism actually counts. And mistake number 3, guys, this is the deadliest one, providing answers that aren't specific to the given context. Writing a beautifully memorized, totally generic answer that completely ignores the provided scenario. That's going to score 0. Your answer has to live and breathe within the specific context of the question.
Oh, and here's a critical examiner alert that you literally need to write down right now. The examiner reports reveal that candidates consistently confuse key terminology in this topic. The easy fix: always define your terms before you apply them in an extended response. Like, if you're going to discuss user requirements, just briefly define what that means in your opening sentence and then apply it to the scenario. It anchors your answer and it instantly proves your competence to the examiner.
To kind of wrap up our procedural framework, here's a quick little memory hack for exam day. Try to think of your answer as a visual story in 3 acts: deconstruct, solve, evaluate. Act 1, deconstruct the prompt and the data. Act 2, solve the problem using your syllabus knowledge. And Act 3, evaluate your solution against the user's original needs. If you can encode this simple 3-step narrative into your study routine, I guarantee you won't freeze up when you're staring down a complex, high-mark question.
All right, I want to leave you with a bit of a provocative question to guide your revision this week. Go look at your past paper answers and ask yourself, are your recommendations built on generic assumptions or are they strictly justified by the specific context of the system provided? The difference between those 2 approaches, that's the difference between an average mark and an outstanding one. So keep practicing those past papers, apply the framework, and absolutely master those specifications. Thanks so much for hanging out with me for this explainer, and I'll catch you next time.